Good morning, everyone. We've got a new lesson today on radians and degrees. Okay, so what we're doing, again, this is using two different types of measurements. You're probably really familiar with how to measure an angle with degrees. Today we're going to talk about radians, what they are, why we use them, and most importantly, how to convert between the two. All right, so here we go. Let's take a look at our worksheets here. Okay, now what I would recommend is you have a notebook that you can jot down a few of these key ideas. And in particular, what we've got to do today, is, again, we're going to take a look at the difference between these two measurements. So let's take a look first at why we would ever want to measure something in radians versus degrees. Okay, so here we go. Let's get our notebook ready. Radians and degrees. Okay. All right. Now, okay. First question, as I said, the reason for radians versus degrees is there are going to be some times where it's easier to use them. So in particular, radians make many circle calculations easier. So that's our first point, right? Why we're doing this, radians make many circle calculations easier. For instance, I used to be an engineer. I designed lasers. So for a lot of engineering, many different types of engineering, electrical engineering, mechanical engineering. So things like if you have to figure out a satellite, in particular the satellite orbit, radians make that a lot easier. You would also use it anytime you're designing electronics. Those are used a lot. And another common thing was anytime you have a rotating circle. Well, that would be used, for instance, in cars for sure. So if you're designing cars, you have to use radians quite a bit when you're analyzing the axis. If you've got yourself a car and you start with a design like this, small wheels, goes a certain speed. If you have that same car, you make bigger wheels, or maybe you're doing a custom car, for the same revolutions per minute, this is actually going to be going faster. Now, there's a lot of calculations. You got to make sure we're not burning out the engine, the crank, the clutch, all kinds of things, as well as just how fast is the darn thing going, right? So again, these are the types of reasons we might want to use radians. Okay, let's get more into the nuts and bolts, though, of just what is a radian. Okay, so what's a radian? A radian, in particular, so one radian corresponds to one radius. Okay, now let me elaborate on what I mean by that. And by radian, what I'm saying here, what I mean by that is the angle measurement. So the angle corresponding to one radian corresponds to an arc length of one radius. Okay, now where this comes down to is this. So I'm going to draw some circles here. Now, just to give you a preview of what's going to be here, just so you have enough room on your notebook, we're going to draw some circles that look like this in just a second. Okay, so I'll put that back again. But I just wanted to let you know we're going to have 4 circles here. So don't make them too big or too small. In particular, let's think about, again, a circle. So I'm going to draw roughly and show you the more precise one in a minute, but just so we're all on the same page, right? So, the best as you can, draw yourself a circle. Doesn't have to be perfect, right? And we're going to have a center, and we're going to have a radius here, okay? Now, that radius, R, right, R. Now, if we were to go r distance along here, that is going to correspond to 1 radian, right? So if I was to get myself a ruler, right, measure this distance, looks like I drew that about 15 millimeters. So if I was to measure 15 millimeters along here, right, roughly there, okay, so that on this circle I just drew, that corresponds to this same distance, right? So this distance here, if I curve that around my circle, that's also 1r, right? That is 1r. That defines what a radian is, okay? So this angle right here that we just drew here, right? This angle right here, that on a circle is 1 radius around, that's considered 1 radian. Now we're going to abbreviate radian as RAD. That's a pretty common abbreviation, RAD. So it turns 1 radian is about 57.3 degrees. Okay. All right. Now you don't have to memorize that number. I'm just kind of giving it to you as a reference. Now, if we were to start working our way around a circle, okay. Now let's draw another circle here. Again, I know these aren't very good circles. I mean, that's why I drew the better ones, but I can just do this a lot faster. Okay. So right, if we went over here, now this is 2 radii, right? So in other words, again, we've got the same thing here going, right? I've got a radius. This is 2 r's, right? So I go from here, I go 1, 2, right? And I'm going equivalent of this twice. Now, this is what we call 2 radians. Okay, now 2 radians is about 114.6 degrees. Again, don't get too worried about this. I'm just trying to give you a rough idea of how big they are. If we were to keep going, and I do this again, I've got a radius here. 3 radii turns out is almost 180. Not quite, it's getting close, right? But 2 radii was almost 100, a little over 114, almost 115. If I had 3 radii worth of arc length, right? 3 r's, then this angle right here, right, from here to here, 3 radians is about 171.9 degrees. In other words, almost 172. Now, you might see where we're getting to. Now remember, this is circles. There's a number that's very close to 3. It's got special significance when it comes to circles. And so what do we got here? Sure enough, you might see this coming. If I go exactly 180 degrees, it turns out that is pi radians. Okay, that's pi radians. So here, I'm going to bring that up here. Pi radians is exactly 180 degrees. Okay, this is the one I do want you to memorize. Super important. Pi radians equals 180 degrees, right? In other words, this angle right here, right? And, oh, I just realized I wrote that wrong. That's not pi radians. That's pi r. I made a little mistake there. Let's fix that. Okay. Pi times r is the arc length there, right? This is pi times r. So the angle we're going to call pi radians. Pi radians. Okay. So again, I'm going to show you a little more precise picture if you want a better picture here, right? Again, 1 radian was about 57, 2 radians about almost 115, 114.6, 3 radians about 172, and pi radians is 180. And again, this is the key thing. I want to make sure you really have this down, right? Pi radians is 180 degrees. That's the foundation for all the conversions we're going to make. Okay, now, I showed you that, but here's the thing. Again, I want to give you a rough idea of what's going on, what's a radian, why we're calling it that. But it turns out that we actually usually specify radians in a different way. We usually don't have radians of like 1 radian, 2 radian, 3 radian. It turns out more often, it just kind of works out this way, that usually, right, radians usually include pi, right? When we're talking radians, usually they're going to include pi in how we specify them. And let's think about that, right? So I said this around here, right? I said pi radians. That's the foundation, right? Pi radians equals 180, right? In fact, let's just rewrite that over here because we want to just keep reminding ourselves. Pi radians equals exactly 180 degrees, right? Key thing I want you to memorize. Pi radians equals 180 degrees. Hey, how much is 180 degrees in radians? You got it, it's pi. Good. All right. So again, we're going to do 4 pictures because I'm going to give you a few common ones. It's going to look something like this. Again, I'm going to do this just by hand, so we're doing it together. Now, the first one we're going to talk about is if we take a circle, all right, and we divide it like this. In other words, this is 45 degrees. This is 45 degrees, okay? Now, remember a second ago, this was pi over here. This is pi radians, just 180 degrees. Well, look, I divided that into 4 segments, right? Half, 4. So therefore, what we're going to say is that pi over 4 radians equals 45 degrees, right? If you have a 45 degree angle, another way to say that is pi over 4 radians because it's half of a circle in quarters. Half of a circle in quarters, okay? Now, let's look at another one, right? And again, that would be this little angle here, right? This little angle here is 45 degrees, otherwise known as pi over 4 in terms of radians. Now, if we look at a 90 degree angle, now remember a second ago, right? 180 is pi, right? It's pi radians to here, so half that, right? Half of 180, well, that's going to be pi over 2 radians. Pi over 2 radians equals 90 degrees. Pi over 2 radians equals 90 degrees. All right, well, so those are a couple really simple ones. Let's actually now look at when we have thirds. When we think about thirds, it's a little bit different. Same basic idea, but of course we're going to get different numbers. Let's think about thirds now. If I was to, again, I'm going to start here. Rather than going a quarter and a half, if I went 1/3 of the way over, okay. Well, 1/3 of 90, let's see, is how much? Well, 1/3 of 180, said that wrong. 1/3 of 180 is 60. So pi over 3 radians equals 60 degrees. And let's look at one where we're actually more than 90, right? We've got an acute angle here. Well, this was acute, and now we're going to look at the obtuse angle, right? If I was to go this far, in other words, 2/3 of the way around, right? 2/3 of the way around. Now I've got 2 pi over 3, in other words, 2/3 of pi, radians equals 120 degrees, okay? So those are just some common ones we think about. Now, I've got them here. I've actually, in this version, I've got them just in order. I just thought it's a little easier to think separately about quarters and thirds, but now you can see them in order, right? Pi over 4 gives me 45. 1/3 of the way around is 60 degrees, right? So that's pi over 1/3 radians. Half the way around is 90 degrees. 2/3 of the way around here is 120 degrees. Okay, right, so that's radians. That's why we use them. That's a rough idea of what they are. So now let's do this. Let's get into making some conversions. Okay, so we're going to do 3 different versions here. First, let's convert pi over 6 radians to degrees. Right? So if somebody said, hey, I've got an angle, it's pi over 6 radians, and you're like, geez, how many degrees is that? Okay, number one thing we always got to remember, right? Let's just, and if it doesn't hurt to just write it down real quick, right? Pi radians equals 180 degrees. Okay, now for a lot of these, what I'm actually going to do is just to keep track of it. It's a little harder to keep track of the degree symbol. I'm actually, in my conversions, going to end up writing a lot of things like this. I'm going to write degrees as DEG. And you'll see in a second, it's just easier to do some of the keep track of things. Okay, so let's do this. Now, if you can remember converting inches to centimeters and all this kind of stuff, my favorite way to do it is the old multiply times 1 idea. And so here we go. So what we do is first we start with the number we have, pi over 6. Now it's going to be easier if we can make everything look like a fraction. So I'm going to say pi radians over 6. Right? So pi over 6 radians, that's like saying pi times radians over 6. Now I'm going to convert. And I always like to do this. I always like to put my conversion factor in square brackets. That's just a personal preference, but I just find it easier to keep track of what I'm doing when I do it this way. Now, some of you guys might remember this one, right? I'm multiplying times the number 1. Okay? Right? We can always multiply anything times the number 1, and it stays the same value. It's going to look different, but it's the same actual value. Now, again, what we do is we say, I want to get rid of radians. Well, if I want to get rid of radians, then radians should go what? The top or the bottom? You're right, it goes on the bottom, right? So I want radians here. I'm turning it into degrees, right? I'm going to degrees, right? So let's put degrees up here, right? And then finally, I put the numbers, right? So let's just rewrite this just so it's obvious, right? Pi radians, right? I'm using this relationship here. Using that relationship to figure it out. Okay, now, right? Radians gets the pi, degrees gets the 180. All right, cool. Okay, well, let's start simple on this guy, right? So first things first, I notice, hey, look, there's a pi. That pi goes away. How cool. Pi goes away. Ooh, radians, that guy goes away too. That's awesome. Okay, and then I can rewrite this. It's starting to get a little messy, so I think I'm going to rewrite it. This is equal to 180 over 6, right? 180 over 6 degrees, right? Well, hey, 180 divided by 6, I know what that is, right? 18 divided by 6 is 3. So that's the same thing as saying 30 degrees. 30 degrees, right? Now, normally we don't actually say degrees DEG, right? I do that so it's easier to keep track of what I'm canceling. So in the end, I'd probably want to say it this way. Probably want to say pi over 6 equals 30 degrees. So my final answer would be that, right? Pi over 6 equals 30 degrees. Okay, well, you know, that kind of makes sense, right? Let's look back here a second. Look, pi over 3 was 60 degrees. So half of that, 30 degrees, yeah, half of pi over 3 is pi over 6. Hey, that kind of makes sense, doesn't it? All right, let's try another one here. Let's do this one. This time we're going to convert 40 degrees to radians. Okay, 40 degrees to radians. Now, again, like I did a second ago, right, we're going to use our handy-dandy conversion factor, right? Pi radians equals how many degrees? You got it, 180 degrees, right? That's what's going to be the foundation for what we're doing. Okay, so let's just start by writing this. But again, I'm not going to write it with the degree symbol. I'm going to use DEG just so it makes it easier to keep track of things. Now, I'm going to write this as a fraction. Right, that's just 40 degrees over 1. I'm going to use my conversion factor. Okay. But this time I'm trying to get rid of degrees. So radians doesn't go on the bottom. Degrees needs to go on the bottom. Radians goes on the top, right? 180 goes in front of that. Pi goes in front of the radians. Now we get to do some canceling again. Look, I got rid of degrees. How cool is that? Oh, here's a 0, right? 40 over 18. Well, let's just simplify that, right? Let's get rid of the zeros. That's going to be 4 over 18. Getting a little messy. Let me just rewrite it so it's clear what's going on. I've got 4 pi over 18. My units are radians, okay? Now, I can simplify this a little bit. Divide top and bottom by 2. And I get that 2 pi over 9 radians, okay, is my answer. Again, that was 40 degrees. Probably want to write that in front just to keep track of what I just did. And then again, you know, let's just highlight this was our final answer here, right? 40 degrees equals 2 pi over 9 radians, or you might even call that 2/9 pi. I'm not going to convert that to a decimal because that just kind of goes on forever. It gets messy. All right, finally, we've got one last example. Just remember that negatives stay negative, right? So if I've got negative 15 degrees, okay, negative 15 degrees, going to call that make that look like a fraction. Okay, and again, I'm going to use the same conversion factors I did a second ago, right? I want degrees on the bottom now. DEG 180 pi radians. Let's do some canceling here. Degrees go away. Okay, no, I'm not going to try and do that one in my head. Let's write that out. Okay, I've got now. Remember that there's a minus sign here. Do not forget the minus sign. Okay, I've got 15 over 180, but I also have this pi. So make sure we write that down, right? I've got 15 pi over 180. Again, this is radians. Now, it turns out 15 goes into 180 12 times. So this is the same thing as saying 12, right? 12 over, excuse me, 12. Pi over 12, 12 is the denominator, radians, right? Pi over 12 radians is the same thing as, right, negative 15 degrees. And again, that kind of makes sense, right? Right? We saw just a second ago, pi over 6 is 30 degrees. Well, half of that would be pi over 12. But of course, we've gone negative. So there's our answer for this one, right? We've got negative 15 degrees equals pi over 6 radians. All right, so guys, that's it for our discussion of radians and pi, and we'll just catch you next time. All right, see you all later.